For the next video, we are going to go over the general settings within SDS2. This will go over both Job and Fabricator settings and how to navigate these settings. Settings are going to be very important to go through at the beginning of the project. This is the most important part of starting a new job as it will affect the outcome of the entire project. We will first start with our job settings. So on our home screen here, I'm going to click on Project Settings. And we're going to start in job settings, and we'll actually start in the design tab. So I'll go ahead and open that up. And in our design tab, we have design settings, plate design settings, moment plate design settings, flange plate clearances, weld design settings, seismic weld access holes, schedule of minimums for structural members, schedule of minimums for single plate shear connections, our field clearances, and our composite reaction factors. So to start, I'm going to open up design settings, and in here is where we could change our connection design method. So when we set up our project, we chose India for our connection design method. This is where you would go to change that if you would want to specify something different. Also, when we set up our project, we saw this round cut dimension. You can either specify 1 millimeter or 5 millimeters. In here is where you'd be able to change that if you specified it wrong when you were setting up the project. Below that, we have the ability to design non-AISC single plate shear connections. And I'll move on down through the tabs over here. So next we have our beam design loads. In here we can specify how our default loads get calculated, whether that is a certain percentage of the uniform allowable load or the maximum web shear. We could check on the minimum setup connection, and what that will do is that will automatically lower the loads until it can pass whatever we have in our setup for our minimum connection information. Below that, we have some different settings for our beam moment connections. So we can specify the percentage of our maximum allowable moment. Do we want to design a moment connections for greater than 100%? We can design for a seismic moment connection design. Do we want to use inner flange plates for beam splice moment? And what our seismic moment frame type is, we can either choose OMF, IMF, or SMF. Next we have connection material specifications. Here's where we can specify what our default material connection steel grades are. So we can change for T sections, angle sections, channel sections, and our base and cap plate schedule. Below that we have our beam composite design. So if we are using composite design, we can specify what our composite loads are, and then what our strength is for, and then what our strength and thickness is of the concrete. Below that we have braces. Here's where we can specify what our percent of allowable tension and compression loads for horizontal and vertical braces is. We have the option to add gusset beam interference forces to beam, so we can pass some of those forces from the braces into the beam connections. And if that is checked, we can specify what our UFM special case design is. What our wide flange vertical brace to gusset flange connection is, we can either specify flange claw angles, paddle plates, or set that to none. And then down at the bottom, what our minimum bolt rows for horizontal and vertical braces is. And since we didn't change anything within this design settings window, I'm going to go ahead and just cancel out of this so that we can get back to our job design settings. And next I'm going to go into our plate design settings. So in here we can specify the distance if we want to design a shared gusset. We can set what our multiplication factor is. Do we want to design by first incrementing the plate thickness or the plate size? Do we want to round our flat plate values? Do we want to always provide our transverse beam stiffeners? We can specify what our minimum beam stiffener plate thickness is, and then what our total stiffener clearance is set to, and then do we want to use HSS column reinforcement plates? Again, I'll go ahead and cancel out of this, and I will go into my moment plate design settings. So this is where you can specify setup for your moment plates. Do we want our stiffeners coped or clipped? Do we want our corner operation for flange stiffeners sized by either total length or dimension added to corner fillet radius? What is our total moment stiffener clearance? When we're framing to a column flange for our web doublers, what is our minimum doubler plate thickness? The doubler plate extension above top flange of beam, the doubler plate extension below the bottom flange of the beam, and then what side is our doubler plate on the column web. We can set that to both near side or far side. Then for flange stiffeners, we can design the depth as needed, when needed use full depth, or use full depth at all connections. And then we have the ability to determine plate thickness by increasing beam flange or flange plate thickness by percentage, by a dimension, or you can just design that as needed. When framing to the column web, do we want to determine the welded moment flange stiffener thickness by increasing beam flange thickness by percentage or dimension? We have the option to extend the plate, and for the stiffeners, do we want those flush to top, centered, or flush on bottom? When framing to HSS column, we have the ability to specify if our flange plates are wrapped around the column. And then lastly, if we want backup bars on our welded connections, here's where we can specify the settings for those backup bars. So we can change the material type, the material grade. If we want to create solids for backup bars and modeling, you can check that option on right here. I'm going to go ahead and cancel out of this window, and I'll move on to the flange plate clearances. So this window allows you to specify your gaps and clearances for moment connections and braces. In this table, we have the ability to specify what the gap is going to be per nominal depth size. So when using a wide flange brace, what is the horizontal brace bottom gusset gap set to? Then we also have the ability to set the gap for the vertical brace paddle plate. And then lastly, what is your maximum gap for a single filler plate? Cancel out of this, and we'll go into the weld design settings. So this is where we can go in and specify all of our basic weld information, as well as our welded moment information. So we have our weld standards up top. We can choose our tensile strength and electrode type. Do we want to perform chamfers? Do we want to show the weld length on symbols? And then for moment connections, what is our weld gap? Our reentrant cut radius, our root face dimension, our web setback dimension, groove angle. We can specify our cut radius, length, depth for our alternate number 1 reentrant. If we do have a reentrant cut, we can specify is that alternate number 3 or alternate number 1. For alternate number 3, cope field shop weld, is the cut type parallel to flange or perpendicular to the web angle? For weld size, what is the minimum for the job? What is the maximum for non-strength connections? For HSS brace weld, what is the maximum field weld for HSS brace? And what is the minimum ratio weld length to HSS brace width? And then for weld pattern, on the base and cap plates, we can specify if we want that 2 faces, all around, all faces, and all faces with a seal. And if you do have a seal weld, what the seal weld size is at the very bottom there. I'll cancel out of this, and we'll take a look at the seismic weld access holes. So if we take a look at the picture here, we can see that the values 1 through 5 are controlling different dimensions for the weld access hole. In this window, we can also specify what the web setback is, what the weld gap will be, and also the dimension for the root face. So in this window is where you would set up your specifications for each access hole type. In this case would be A through O. And then in the local material file is where you can set the designation for which access hole type you would want to use. I will go ahead and cancel out of this. We won't go into the schedule of minimums as this will be covered later on. Next, I'll go into field clearances. So for our non-auto standard connections, we can specify what our field clearances are going to be for shear plates, shear tees, our clip angles on supported or supporting, end plates, seats, splices, or plain end. For our brace connections, when it is braced to another or braced to gusset. For joist connections, when it's plain end and bearing, or whether it's a seated bottom cord extension or knife plate. For welded connections, when it is braced to supporting member or brace to brace. For our end plate field clearance, if we want to round up the field clearance or not. And then for our steel to concrete connections, what is our end and pocket clearance, and what is our pocket grout thickness. So we'll go ahead and cancel out of here. And lastly, we have our composite reaction factors. So based on our nominal depth of the members, what is our RX factor? This allows you to set a percentage or a factor of what the composite design is going to be designed for. I will go ahead and cancel out of this. And next we're going to be taking a look at the settings for our bolts, washers, and holes. So to get back to our settings, what we can do is we can simply just go up here and click on the Job button here, and this will take us back to our main fabricator and job settings. And now what we can do is click on our bolts, washers, and holes tab. Inside of the bolts, washers, and holes tab, we have bolt settings, bolt specifications, nut and washer schedule, washer settings, and our user slot lengths. So to start, I will click on our bolt settings. And inside of here, we can specify what our default bolt class is. Do we want to make all bolts automatic, field bolts, or shop bolts? With this set to automatic, the system will automatically decide on which bolts will be shop and which bolts will be field bolts based off of our project settings and what our particular framing situation is. Below that, we can specify what our minimum bolt length is, what our min and max stick through is. Do we want all metric bolt lengths in 10mm increments? Do we want washers to prevent shank out when needed? What is our maximum bolt gaps for field bolts and shop bolts? And then we can specify our available bolt diameters. These are the bolt sizes that we want to specify to be allowed inside of this project. What is our hole allowance? Do we want this based on job units, our bolt units? Below that, we have our default bolt criteria. What is our default for our non-moment bolts? So we have the ability to change our bolt diameter, and if I change this, I have the option to apply to all auto standard connections, and then the same for the bolt type. I could change the bolt type there, and if I do, I can choose to apply that to all auto standard connections inside of the project. We can also specify our moment bolts, our vertical brace gusset to supporting, and horizontal brace gusset to supporting, and then a series of different joists. So we have K, KCS, LH, DLH, and SLH. We have G joist bolts, BG, VG joists, and CJ joists. You can change the flush frame joist connections and our HSS welded brace erector bolts. And then lastly, at the bottom here, we have the ability to specify our bolt edge distances based off of what our bolt size is. So I will cancel out of this window and I will open up bolt specifications. This list is based off of our design method that we chose, which in our case is set to India. In here we have listed our bolt type, the bolt grade, what our connection method is going to be. We have some different hole factors, our yield strength, ultimate strength, and our nut grade. If we wanted to add in our own bolt specifications for one that isn't listed here by default, we could do so in one of the empty spaces down below. We'd want to make sure we have all of these fields filled out all the way across, and you'd want to ensure that you have the appropriate yield strength and ultimate strength filled out, as this will affect how your calculations come out. We'll close this and open up the nut and washer schedule. Here we can specify the grade name and nut type. For the nut types, you can have heavy hex, heavy square, or jam nuts. And then in a washers tab, you can specify the grade name and the washer type. And for the washer type, you can see listed down the list here, we have hardened, flat, bevel, direct tension indicator or DTI, square plate, round plate, hillside, or a material plate. Go ahead and cancel out of this and go into the washer settings. This is where we can define the default washers to use for each hole type in different configurations. So these up top will be our default thicknesses for our different washer types. We can then down below go in and specify by bolt type what we want to use for what type of washer. So for standard holes, we can specify a primary or secondary under the head and under the nut. We can specify based on the hole type, what washer we want, and how many washers we want. And then we also have the options to be able to use tension control or TC bolts. And we have that ability for both shop bolts and field bolts. If I cancel out of this, I'll click on user slot lengths. So this will allow us to set up user-defined slot lengths based on bolt diameters. You have the option to set up for slot length number 1 or slot length number 2. The default long slot and short slot lengths will not be affected by this window. This is a completely separate user-controlled slot length. Now I will cancel out of this, and I will go back to my job settings. And next we'll be looking at our material grades. Material grades is where you can go in and set up your default steel grades and production standards for different material types. So if I click on the angles here, we can see that we have some default steel grades set up for angles. If we do want to set up our own or add in our own steel grades, we can do so, but the same applies here as it did for the bolt steel grades. If you add in your own, be sure to appropriately fill out these fields as they will contribute to how the system makes these calculations. The first line in this window that says default 1 will be the default grade used when adding those material types and will affect any material that is already added into the model. You can always come into this window, select the steel grade, and use the move up or move down buttons to make adjustments to your steel grades. So if I wanted to move this one down, say, I could use these buttons to move that line up or down. I'll leave that be our default for now. And these same settings can be applied for all of the other materials, such as our cruciform, channel, flat bar, grading, HSS TS production standards, HSS TS grades, pipe, plate, rebar, round and square bar, shear and threaded studs, our turnbuckle and clevis, and pins, our wide flange grades, and our WT grades. I will go ahead and click on Job again so we can go back. And next we have our Modeling tab. If I click on Modeling, this will allow us to set up general modeling settings. We can set descriptions, revisions, some different color settings, and some offsets. You can also set up different zones and sequences. And for this project, we will need to do so. So we can go ahead and open up our Zone and Sequence tab. And right now you can see we only have one sequence set up. We need to change that to 4. So for our maximum sequences up here, we can just type in the number 4. And once I tab out, you can see that down below, our sequences automatically change 1, 2, 3, and 4. And that's set up for our zone number 1. So if you wanted to have multiple zones, you can come down here and change zones, and then you could apply which sequences go with which zones. In this case, we're just going to have one zone, so I will keep the one zone with the 4 sequences. And now what we're going to do is we're going to rename these sequences. So to do this, what I can do is go down here to sequence names, and then I can just type in what I want my sequence name to be. So in this case, I'm just going to rename that to 1A, rename this one to 2A, 3A, and 4A. And then you can just say OK to this window. And you can see that that change gets made under the sequences up top there. Now that we're done with that, we can say OK to this window. And I will go back to our job settings. Next is our custom properties. In this basic training course, we won't have enough time to get into any of these settings, but this is where we'd go to set up custom properties for job properties, member properties, material, hole, bolt, and weld properties. We do have our concrete and rebar tabs down here, which we won't get into right now, but this allows you to set up concrete and rebar information if you do have that information present. For now, we will go over to our fabricator setup. So our standard fabricator connections is where we can go in, and this allows us to set up defaults for different types of connections. We will be taking a look at this a little later on in the course. So for now, I'll just hit fabricators to go back to the main project settings screen, and we'll move on to piece marking. In here, we can specify our standard marks for all bolted clip angle connections, our bolted welded clip angles, and all welded clip angles. We'll take a look at this later on as well. Next, we have our standard piece marks for shear plates and end plates. And then we have our member and material piece marking options. If I open that up, here I can specify the main member information from this tab. Do we want to break major marks apart by field bolts, sequence, zone, individual member, or do we want them not broken at all? We have the option to use member mark for member main material in shop bill. This will only call out the member mark for that member's main material in the bill of material and not in the model. So your bill of material would differ than what would be shown inside of your model. And if that option is checked on, you will then have options to show the submaterial mark for beams, columns, vertical braces, horizontal braces, and miscellaneous members. You have the option to use member mark for member main material in shop bill of stair member details. You have the option to show submaterial mark for main material on stair member details. Below that, you can use member mark for member main material in the model. This option is very similar to the first one, but this is going to apply inside of the model. So if you remember, anything that is in the model carries over into your drawings, so that way your marks would match both inside of your model and inside of your bill of material. Next, we have the ability to show linear measure for handrail in shop bill. We can show linear measure for rails, posts, elbows, and grab bars. We have the ability to show submaterial mark for posts and rails on handrail member details. If we go up top, we can change to the submaterial tab. In the submaterial tab, we can set our designation for our primary and secondary submaterial marks. Do we want that to be piece mark only, material type and piece mark, material type, size, and piece mark? What is our starting number for material piece marks? What is our default designation for user added material callout? Do we want a quantity included in our user added bolt callout? Our default designation for user added bolt callout, is that bolt type only or bolt size and type? We can show submaterial quantity on submaterial details. We can show member marks and quantities on submaterial details. Do we want to prefix imperial material callouts that are less than 12 inches with a 0 dash? We can break submaterial marks apart by sequence and by zone. And if we have those options checked on, we can include the sequence or zone in the submaterial mark. We can indicate near side and or far side of submaterial in main view on details. We can show non-standard grade notation with piece marks on member details. We can show piece mark for submaterial bolts on member details. Do we want to reuse piece marks? If this option is checked on, anytime you close out of the model, any mark that was in there at one point but is now no longer inside of the model will become available to be reused. We can force flat bar descriptions to use smaller of length and width, force bent plate description to use the smaller of length and width first. And we want to show piece marks in all views on member details. In the group tab, for submember piece marking options, do we want to combine all like submembers contained within all grouped members, or do we want to combine all liked submembers by same grouped member piece mark? And we can specify if we want to use member mark for member main material in shop bill of group member details, and do we want to use group mark for main submembers main material mark in the model. And next we have prefixes. So this will allow us to change any prefixes for any of our material shapes. We also have the ability to rename the description prefixes for plates down here as well. I'll go ahead and cancel out of this. Next we have our member descriptions. In here we can specify what we want different member descriptions to display as on our member details as well as in the bill of material. And then the piece mark prefixes tab. Inside of here we can specify how it's going to call out our piece marks inside of our model, and also when we go to do our detail sheet auto loading, what designation do we want to use for our different member types. I will cancel out of this and go back to our Fabricator options. Next we have our Sheets and Reports tab. This allows us to set up the bill of material, sheet revisions, and loading options. After that we have our Detailing tab. Inside of the Detailing tab we have a lot of different settings we can set up. We'll start looking at dimension settings. So across the top we have our General tab, Beam, Column, Brace, and Miscellaneous. So under the General tab we can specify our dimension terminals. Do we want arrows or slash? Our submaterial sloping hole layout dimensions to on work line, farthest hole, nearest hole, or none. Also the same for our main material sloping hole layout dimensions. For our main material sloping hole extension dimensions, do we want that to go to the top leftmost hole, the bottom leftmost hole, the bottom rightmost hole, or the top rightmost hole? We can show point-to-point distance on main dimension. We can show material grade on main dimension. Do we want to show on radius dimension for arc dimensions? Show angle dimension for arc dimensions? Either no, as degrees, as radians, or as degrees, minutes, and seconds. We can specify if we want to break dimension lines at label interference, if we want to break material lines at label interference, or if we want to break the bevel lines at the label interference. Do we want to combine dimensions across detail? Our extension dimensions on submaterial details. We want extension dimension tails on submaterial details. What our material point dimension holdback distance is. For drawing editor system generated details and submaterial detail restrictions, we can specify if we want to lock the outline layer or lock manual editing of dimension text. And then our display measurement unit for angle dimensions as degrees, as radians, and then we can specify our angle dimension precision. We'll switch over to the beam tab. For beams, do we want to show extension dimensions? Do we want to show extension dimension tails? Or the extension dimension origin? Do we want to dimension reference points on symmetrical web holes or flange holes? Show chain dimensions between hole groups? Show extension dimensions from left or right? And then extension dimensions from bolted, welded, and specify if that is from the end of beam or the face of connection. Same for copes dimension from. And do we want to show end of beam to face of clip angle dimension? For columns, the same similar type settings. Do we want to show extension dimensions, to show extension dimension tails, or origin? The dimension reference point on symmetrical web and flange holes. Show chain dimensions between hole groups. The show extension dimension is from the top or the bottom. Extension dimensions from the top of plate or bottom of plate. And then our overall dimension from, for cap and base, do we want that from top of plate or bottom of plate? For the brace tab, for horizontal braces and vertical braces, do we want to show extension dimensions, the extension dimension tails or origin? We want a dimension reference point on symmetrical web or flange holes, show chain dimension between hole groups, and show extension dimensions from left or right. And for the miscellaneous, we can show extension dimension tails. For our rolled plate lengths, the rolled plate width dimension, is that taken from the outside, center, or the inside? For our bent plate lengths, do we want our bent plate lengths calculated at centerline for all plate thicknesses, or do we want to use a custom K factor? Our unfolded surface template bend lines, we want to show beginning and ending bend lines. And then we can have the option to choose the pen color and line type for our beginning bend line, our center bend line, and our ending bend line. Since we didn't change anything in any of these tabs, I will go ahead and say cancel here. And we can go into our drawing presentation. Inside of our drawing presentation, we have a lot of different tabs in here which we'll go through. So starting at sizes, you can specify what our label's character height is, what our label's width height ratio is, the section size character height, and the section size width height ratio, as well as our piece mark character and our piece mark width height ratio, what our weld symbol's character height is. Can choose our size of dimension terminals, our size of pointer arrowheads, and our size of work point symbols. Next, we have our fonts. In here, we can choose the font and font style for labels, dimensions, symbols, member labels, member piece mark labels, member section size labels, our bill of material, and our sheet revisions. Next would be our pens. In here you can choose the different color you want for your different bill label pen, detailing label, our pointer, section size, piece mark, member, cloud, weld, dimension, bevel, grid line bubble pen, filled hole, hatch pen, and our member detail pen color. Next is our bill of material. Our spaces between fields in the bill of material, do we want 1 or 2? Our bill items character height. We can specify our bill items width height ratio. Do we want to show grid or wrap fields to next line? We can specify what our rotation is, what our outside and inside pen color is. We can set up what our maximum spacing between items is and our maximum and minimum number of rows. We can choose what our title text is, what our title character width height ratio is, and then we can choose our title font and font style and our header font and header font style. Next would be our revision chart. So some similar settings. Do we want to show grid, wrap fields to the next line, how many number of lines we have, what our header position is, our order of revision lines, is that top to bottom or is that bottom to top, what our rotation is, our anchor location, is that upper left, upper right, lower left, or lower right, what our character height and character width height ratio is, and then what our column title font and font style is, as well as our outside and inside pen colors. For tables, what is our outside and inside pen color, our rotation, our anchor location. Do we want to show grid? For our header on tables, we can choose our font and font style. Our justification is at left, center, or right. Our character height and our character width height ratio, and what our pen color is, and the same exact settings for our body for tables. Next would be our primary dimensions. So for our primary dimensions, do we want to use our imperial or metric units? This, when we set up our project, we specified we wanted to use our metric units, so that's where that comes from. We can lock primary units. We can change our character height and character width height ratio. Do we want to expand dimensions less than or equal to? And then we can change our dimension precision, as well as our dimension label pen color. Next, we can choose to show our secondary dimensions. If we have our show secondary dimensions option turned on, we have the same exact setup options for our primary dimensions. Do we want those units to be imperial or in metric? We can choose our character height, our character width height ratio, and our pen color. And then lastly, we have our colors. So these are for our different layers. If we want to specify our user adjusted, layer color, our detail rule annotation, reference dimension, user annotation, system annotation, our outline, new comment layer, or new layer color. I will cancel out of this window. Next, we'll take a look at our line weights. In here is where we can specify our thickness and color of our pens when we are plotting. The pen numbers you see here are going to correlate with our pen colors, in which we already looked at inside of the Drawing Presentation tab. So as you can see here, pen number 1 will correlate with the color white. Color red will be for pen number 2. Yellow will be number 3. Green will be number 4. Cyan will be number 5. Blue will be number 6. And magenta will be for the number 7 pen color. I'll cancel out of this line weights window and I'll move on to the general presentation. Up top here for detail scales, we can specify our default member detail scales as well as our submaterial detail scales. We can choose our default member detail scale by our nominal size. We can choose what our rolled section standard edge distance and our plate material standard edge distance is. We can also show non-standard edge distances. Marked for detailing, we can clear detail flag when detailing current piece mark. You can either prompt, never, or immediately. And our prompt default is that set yes or no. For shop bill weight, we can specify our shop bill weight precision. Do we want to always round unit weights up? For our weights, do we want those to always add up, or do we want to the actual total weights? For shop bill weight based on material, do we want volume or dimensions? Dimensions will include any cuts or holes that are in that material. It will not subtract those weights. Whereas if it was set to volume, the system will account for those cuts and holes and it would subtract the weight out. For detailed drawing options, do we want to show cross hatching? Do we want to show cut surface hatching? Face AC holes shown in face CA view on member details. And we can also show face BD holes shown in face DB view on member detail for cruciform columns. Can show main member size. Can show the K distance with main member size. Do we want to show some material layout dimensions on our member detail? We can show shop bolt slotted holes, and we can specify our minimum slot length. Do we want to use curved pointers? We can use pointer face indicators. And for our single quantity designation in main callout on details, do we want it 1 as it's spelled out or just the number 1? I will cancel out of this general presentation and we can go into our bolt detailing settings. So for bolt designation shown on details and reports, do we want bolt material only or bolt material and type? Are field bolts listed on which members, the supporting or the supported member? Do we want to plot field bolt bill of material information? We can summarize field bolt list in bill of material. We can include unit quantities and weights for field bolts in the bill of material as well. Do we want to summarize like field bolts on details? We can list washers and secondary nut with field bolts on details. We can specify if we want to summarize like shop bolts on details, as well as list washers and secondary nuts with shop bolts on details. Our bolt summary format on details is that unit quantity, total quantity, or unit and total quantities. For our bolt, nut, and washer callouts, we can include units of measure. And do we want the diameter symbol displayed? Do we want to spell out DIA for diameter, or do we want it set to none? And we can also have our bolt, nut, and washer broken out in bill of material. I'll cancel out of here and move on to the connection erectability settings. We have the option to use oversized holes in beam moment flange plates. We can choose our default section size for our angle, our stability angle. We can show field bolted stability angles either on the beam, on the column, or have them shipped loose. What is our maximum amount of allowable K infringement? Do we want to use backing bar for pre-qualified welds? And do we want to do weld prep on moment flange plates? For our safety erection seat options, we can specify our default section size for the seat angle. Our safety erection seat connection to supporting, is that bolted or welded? Do we want to attach the long leg to the supported or the supporting member? Our gauge on leg to supported and supporting member? And what is our gap for safety seat on bottom flange? And then down below here we have some bolt detailing options. So based off of what your bolt size is over here, we can specify what our spacing is, what our tension controlled tool type is that a large or small? And then we can specify what our, for a non-tension controlled tool and a large and small tension controlled tool, these different values, so we can specify what our H1 is, our H2 distances, our C1 diameter for large and small, our C2 and our C3. Go ahead and cancel out of this. And for our member detailing settings, we will go down the list here of each different tab. So to start off with beams, do we want our preferred bottom flange view style set to cross section or a worm's eye view? We can provide our minimum cope depth, what our minimum clearance for cope is, what our minimum cope radius center clearance from face of flange, what do we want a round cope length or depth to nearest. We can specify what our cope radius is. Our cope cut type, is that perpendicular to the web angle or parallel to the flange. We can round off material length where possible. We can specify what our member end edge distance is. Do we want to square cut ends of sloped beams? We want to square cut ends for spliced beam connection. Detailed, for beam member details, do we want those in position or horizontal? If you had a sloped beam and that was set to in position, the detail would also be sloped. If it's set to horizontal, that detail will always be horizontal even if the beam is sloped. We can specify if we want to show design loads on details. We can either have that set to none, input, or all. And if that is set to input or all, we can show member quantities or show member numbers. Same goes for our capacity loads on our details. Do we want to show grid notes on details, either none, one, or all? We can show end elevation on details, none, first, or all. And our end elevation reference point, is that coming from our material end or our work point? We can add work point dimensions, and we can show camber on the bill of material, and we can specify how that looks. So right now that is C equals. Moving on to our columns, we'll have the same similar type settings. In here we can specify if we want to see our preferred baseplate view orientations as a bird's eye view or a worm's eye view. We want to show C face on details, either as required, always, or never. And the same settings for A face on details. Do we want to annotate faces of pipe on details? We want to mill cut column ends. We can show erection pinholes, and if that's option checked on, do we want to make our erection pinholes CNC downloadable? Specify what our erection pinhole diameter is and what our vertical edge distance of the hole. Do we want to detail columns in position, vertical or horizontal? We can show design loads and capacity loads, either none, input, or all. And do we want to show member quantities or member numbers for those? We can show grid notes on details. We can show end elevation on details. Our top elevation reference point, is that coming from the material end or work point? And we can show sections framing into a column. And then a sub tab of the columns is our shear through plate. Have a couple different settings here. So for our shear through plates on columns, we can specify our HSS notch radius and what our total notch width clearance is. Next, we'll go to vertical braces. We want to locate angle braces on neutral axis. We can specify what our minimum member end edge distance is. Our gusset to supporting member is at welded or clip angle. Do we want to detail vertical braces in position or horizontal? We have the same setup options to show design loads and show capacity loads. Do we want to show grid notes on details? We can show end elevations at work points on details. Our HSS erection bolts, is that none, 1, or 2? Specify what our hole type is for HSS erection bolts. Intersection gusset notch preparations. Do we want a rounded slot or weld a round end? What is our HSS notch radius? Our total notch width clearance, and our HSS double paddle clearance. We want a welded angle end weld or welded angle balance welds, and what our maximum web stiffener thickness is. And then a sub tab of the vertical braces. For clip angle connection of gusset to supporting member, our gusset to clip connection is that welded or bolted. Can specify our default clip angle section size. Do we want to attach the long leg to supported or supporting? Our hole type for supported and the supporting. We can specify our gauge on the supporting and supported member. Do we want to stagger bolts? And use expanded bolt spacing. Moving on to horizontal braces. Some of the same similar setup options. We want to locate angle braces on neutral axis. What our minimum member end edge distance is. Our gusset to single beam connections, is that welded or clip angle? Do we want to detail horizontal braces in position or horizontally? Same setup options to show design loads and capacity loads. Do we want to show grid notes on details? Our back-to-back angle stitch plate gap, we can specify what that is. Do we want to allow material work line offset? Our HSS erection bolts, is that none, 1, or 2? Our hole type for HSS erection bolts, we can specify what our HSS notch radius is, what our total notch width clearance is, and our HSS double paddle clearance. Do we want welded angle end weld or welded angle balance welds, and what our maximum web stiffener thickness is. And again, a sub-tab of the horizontal braces, our clip angle connection of gusset to supporting member, The gusset to clip connection, is that welded or bolted? And the beam to clip connection, is that welded or bolted? Do we want to attach the clip to gusset or supporting? Do we want to attach the gusset to brace or supporting? Gusset clips, do we want to specify them on both sides, near side, or the far side? Can specify what our default clip angle section size is. Reattaching that long leg to the supported or the supporting member. Can specify our hole types for the supported and supporting members. Our double gauge on supporting member, and what our single gauge on supporting member is. Our gauge measured from gusset center line or GOL, gauge on leg. Specify what our gauge on supported member is. Do we want to stagger bolts? And then our clip to gusset dimension. Moving on to handrail. Do we want that noted at top rail from not noted, top of top rail, or center of top rail? And we also have option to be noted at the bottom of the post. Moving on to stairs. Our preferred stringer auxiliary view orientation, is that from the outside or the inside? And our new stair stringer length on bill of material and detail, is that pre-cut or post-cut? For stitch plates, you can specify a type of spacer for double bracing. You want a bolted ring, bolted plate, or a welded plate. Type of spacer for welded connections. Our max allowed stitch plate spacing. So our minimum number of allowed stitch plates. So our stitch plate extension beyond brace and our stitch plate width. If those are set to auto, the system will automatically decide on what those distances are. For miscellaneous, we want our miscellaneous members detailed in position, horizontally, or vertically. We can add bearing bar thickness to description in the bill of material for grading material. And we can also add bearing bar thickness to description in bill of material for grading tread material. And then for tension only braces or rod braces, our length of bottom rod for rod bracing. What is our length of rod brace thread? Specify the gap between rod braces at turnbuckle. And for our pin type, is that a headed or cotter pin? So I will cancel out of this. And next is our member view defaults. So based on the member type for each view that comes in here, we can specify what our in and out depth is. We will leave all of these set to be default or auto. If that's set to auto, SDS2 will automatically set these distances for you. You can also do the same for your material view defaults. If you wanted to specify something different for any material, you can do that as well. We will leave all of our set to auto. I will cancel out of this window here, and next we will look at our detailing defaults. Here we can specify for our members, group members, or submaterial how those will be detailed. So to go down the list here, we want to preserve existing drawing annotations. You can either preserve none, preserve user created, or preserve all, ignore drawing piece marks, or all, update drawing piece marks. You can check on if we want to detail using templates. Do we want to remove snap lines, verbose progress updates, can show applied templates. Do we want to dimension user created material, dimension holes on user created material. We can show non-annotated system views. We can preserve system set detail flags, preserve user modified bill of material. We want to detail with revisions, and to shorten drawings. I will cancel out of here. Next is our non-standard field bolts on erection views. Here we can specify how we want those non-standard field bolts called out on erection views. Detail erection view defaults. We will take a look at this a little bit later on when we start detailing our erection views. Our detailing symbol settings. We can specify what our bevel symbol base dimension is. Do we want to show bevel angle degrees with bevel symbol? We can combine weld symbols. We can allow weld symbol to be drawn on material. Do we want to use pre-qualified weld tail text by default? Add weld leader cranks always or as needed. Can allow hole symbol to be drawn on material. Allow piece mark to be drawn on material. Do we want to show paint stripe on framing side of shear plates? You can show non-standard hole sizes on detailed drawings. You want to show non-quad boundary slot rotations with symbol note on detailed drawings. You can call out standard holes with mixed bolt hole units on details. Our designation for non-standard holes on details is at cloud or pointer. And then the cloud and note holes having slip critical bolts on member details, and we have 3 lines that we can specify what we want there if that option is checked on. Next is our galvanizing settings. Under this general tab, we can specify some different kettle defaults. Do we want to automatically break apart galvanized members? Galvanized member default material surface finish. Do we want that galvanized or duplex coating? Our default vent drain hole diameter, and what our default vent drain hole plug type is. Add galvanized duplex coating label to remarks column in the bill of material. You want to add no chromate quench note to detail for members with the duplex coating. And we can cloud and note vent drain holes on member details. We'll cancel out of the galvanizing settings. Our erection view member labels we will not get into. CNC center marks. Do we want to show the center marks by default? Position and match marks. Do we want to include position marking where it would go through and it would add in pop marks for your different framing situations here? In this case, we won't go into any of these settings. I will go back here to our fabricator settings. Below our detailing, we have our concrete and rebar. If we had concrete and rebar information, this is where we could set those settings up. In this case, we don't, so we won't get into it. Our crane limits and appearance. This will allow us to specify how cranes are shown. Stair treads is where you would set up your default tread types. We will go into this further later on in the course when we start working with stairs. Our category settings, we can specify any categories we may need to. User routings. This will allow us to set up user routing definitions to be used in our job, which we won't really get into these settings at all. And we have our project output. This will allow us to specify our default output areas for reports, drawing conversion, CNC, BIF, estimating, production, our design link, model link, and parametrics. And then lastly, if we wanted, we could print out our fabricator settings.